All right, so number 11. It's an exponential equation we got to solve, but we turn it into a log problem. So what we're going to do first on this, again, you should have your little cards out. You can write down what you need to do, on this type of problem, because you can have that with you. So I'm going to take the log of both sides first. Nothing else changed yet. I just took log of both sides. And since I turned it into a log problem, what can I do with those exponents? I can move them out front. I can put them on the same level. So this x plus 2 can go in front times log of 4. And then this x times log of 8. That's the reason we do that, so we can get the exponents on like ground level instead of exponent level. Now the next thing we always do is take the log on the left over to the right. Since this is multiplication here, I divide both sides by the log of 4. So those will cancel. I'll just have x plus 2 over here, and then log of 8 divided by log of 4, I'll do on my calculator. Most of you should know that it's, 2 squared, that's 1.5, I think, but most of you probably don't know that, which is okay. So log of 8, close it off, remember, when you hit that log button, gives you that left parenthesis, log of 4, you get that 1.5, okay? So you got this x times 1.5, which is 1.5x, right? So now you got to get your x's together to solve this. So I'm going to subtract the x over. So what's 1.5x minus 1? Remember, that's 1.5. I just didn't write it in front, okay? 1.5x minus 1x is what? Come on, people, wake up. I know it's Monday. Come on. Last week, you can make it.
Attention, seventh
All
grader.
right? That's 1/2, right?
Release
1.5 minus 1 is 1/2.
Go to the pond
Okay,
or the
so
salad cell. Thank you
divide
very
by
much.
0.5 or multiply by 2. And we get x is 4. Okay? Questions? So that's how I would do a problem with exponents. A variable in my exponents, an exponential. All right? Number 12. This is logarithmic. We're going to turn it into exponential. Remember, this is the base. This 4 is the base, right? So what I can do is say 4, I can do that swoosh thing we learned, to the third power is x minus 2. That's all you got to do. Then you just solve it. 4 times 4 times 4 is 64, I believe. And then add 2. That's number 12. So just turn it into, so what we basically did when we did that logarithmic chapter, which is chapter 6 stuff, okay, is we turned exponential equations into logs and then log equations into exponentials. All right. Number 13, all we have to do is express it as a single log. Remember, addition we could turn into what? Come on. Addition turns into multiplication. Subtraction turns into division when we turn it into 1. All right, so all I'm doing is turning this into a single from 2. That's called, we did expanding when we made more, and then we did condensing when we made a single. So we leave it in this 125 over 5. Well, you know what 125 divided by 5 is? It's 25. So there's your single log. The answer would actually be 2 if we went further, but all we had to really do was turn it into a single log. So that's it. We did. We turned it from 2 to 1. So remember, addition you could turn into multiplication, and subtraction you could turn into division like we did. All right, number 14. All this is calculator stuff. Okay? There's a rule that we've learned since it's a log. We used it on that first problem we did today. We can put that out front. So I can rewrite this as -5 times log base 4 of 16. We learned this change of base formula, which was log of the 16, the big number, divided by log of the base. So that's all we put in our calculator. Okay? That's exactly how I'll put it in my calculator. The base, remember, goes in the basement or the bottom of your fraction when you put it in your calculator. So, -5 times log of 16 divided by log of 4, and you get -10, which is the answer to number 14. All right, so 14 and 15, you're just going to use your calculator. All right, we're going to do the same thing for 15. I'm just going to put it in the calculator. Use that change of base formula. All right, so we're going to go log of 10 divided by log of 4. 4 is the base. The base goes in the basement, right? So just a calculator problem. Log 10, close it off, divided by log 4. Close it off. 1.66 we'll just use. Unless it did tell us to go a certain. So I think when we did these, we did hundreds or thousands, but I don't remember. Okay? Any questions? That's chapter 6 stuff. Logs and exponentials. All right? Chapter 7 stuff. All right? Vertical asymptotes and graphing. All right? And you can remember when you put these graphs in your calculator, make sure you put parentheses if you have more than one term around them. So you have 2 terms in the top and the bottom, so put parentheses around when you put it in your calculator. All right, so you're supposed to graph it, but usually we did find the asymptotes first. The vertical asymptote is what makes the bottom 0. Okay, so add 1 and divide by 3. All right. And then the domain goes the same with it. Those go together. So domain is x, same number, but instead of equals, we put is not equal to. All right. Then we find 1/3, which is really close. You know, it's to 0. And we would make a dashed line. That's how we did it when we did these. All right. Then the horizontal asymptote, when we had this form, was the coefficients. 4/3. Okay, the coefficients of the top and the bottom, that first term. All right, and then our range went with that, and it was not equal. Right, 4/3 is 1 1/3, so it's a little bit past the 1. Okay. So then when we put it in our calculator, it's probably going to be top right and bottom left. That's what the positives usually were, but we'll make sure. All right. And remember, parentheses when you put in your calculator. 4x plus 2 divided by parentheses 3x minus 1. And your graph. Yep, bottom left, top right. So remember, asymptote is what your graph approaches but doesn't actually touch. So make sure it doesn't cross those dashed lines. It can cross the x or the y axis, that's okay. Just not your asymptotes. That wasn't that long ago that we did those. Any questions? All right. On these, we found a common denominator. We wanted to get rid of the fractions first. Can I factor any of the denominators? No. So whatever shows up, what did I tell you to do? Write it down. Things jumpy again today, huh? All right, so I'm going to multiply everything by the x that I saw and the x minus 2. Remember? I can't factor either one, so my common denominator is just writing them both down. All right, when I multiply the 5 over x minus 2 times the x and the x minus 2, the x minus 2's cancel, so all I'm really multiplying is the 5 times the x. And that fraction's gone. When I multiply 2 over x times those two, the x's cancel, so I'm multiplying the 2 times the x minus 2. And then the same thing here with the x plus 3 over x minus 2, the x minus 2's cancel, so it's x times the x plus 3, or x plus 3 times x, however you want to think about it. So that way we got rid of the fractions right away. So we use the common denominator, multiply each fraction by it, and that'll eliminate the denominators for us. No more fraction stuff. Now I'm just going to distribute and solve it. All right, so I'm going to multiply by -2 on the left and by x on the right. Since it's got an x squared in it and it doesn't get canceled out, I'm going to have to take the stuff on the left over to the other side, have it equal to 0. Okay? So this is 3x, 5x minus 2x. So I'm going to subtract 3x and I'm going to subtract 4. So all this canceled out. It gave me 0. That's what I wanted. And here I got x squared, and these canceled out. So there's my equation. Okay? How do I factor that? That's a difference of squares. Nobody can factor that? Square root of x squared. Square root of square root of 4 is 2. One's plus and minus. So this x is -2, and this x is +2. We're supposed to check. All right? Go to the original problem. So if I put -2 here, here, or here, do I get 0? -2. No. So -2 is a good answer. What if I put +2 here? What do I get? 0. Is that a good answer? No, you're not allowed to have 0 on the bottom, right? So there's only one answer. Even though we got 2 of them, the only one that really worked was the -2. All right? So check that, those details we talked before. Any questions on 17? Okay, 18. Find the quotient. Division we turn into multiplying by the reciprocal, right? This isn't written as a fraction. To write it as a fraction, I just put it over 1. To write anything as a fraction, you guys should know that. Put it over 1, right? So I'm going to factor what I can factor. and these two will be able to factor, times reciprocal 1 over, then I'm going to factor this one. All right, so up here, factors of 2 that give you -3 are -1 and a -2. Factors of -8 that give you 2 are a +4 and a -2. Factors of -3 that give you +2 are a +3 and -1. So everything's factored. You guys should be able to do that. Do you see any common factors, top and bottom? You do, don't you? You see an x minus 2 in the top and the bottom? I see an x minus 1 in the top and the bottom. All right, so what's left in the top? Anything? Or is it 0? 1, thank you, Sabrina. 1 is left in the top. If everything cancels, remember it's a 1. Each time I cancel common factors, those make 1s, those make 1. Something over itself is 1. You guys should know that. All right, in the bottom, I've got an x plus 4 and an x plus 3. So don't forget to write those. So there's the quotient of number 18, the division problem. Remember, dividing is multiplying by the reciprocal. Number 19 is an addition problem. Before you can add two fractions, you have to have a common denominator. This denominator we need to factor first. And it factors into x minus 7 and x plus 3. So that's my common denominator. Whatever shows up, I write down. I see an x minus 7. I see an x plus 3. I see an x minus 7 again. I don't have to write it twice. So there's my common denominator. All right, so look. Here's the original denominator. Here's the common denominator. Is there anything different? No. So do I do anything to that 7 up there? No, it stays 7. Now, this one, I had an x minus 7. What did I do to it? I multiplied by x plus 3. So I got to multiply the 2 by x plus 3. So that's what changed for the second numerator. I had to rewrite it a little different. So the next thing I have to do is distribute the 2 first. And then I can add them. Rewrite your fractions with the common denominator, then you can add or subtract. So combine like terms, I got 0 plus 2x, no other x's is 2x, and I got 7 plus 6 is 13. That won't factor. I think we were saying also we couldn't have x equals 7 or -3. I think we had restrictions. I don't know if I asked for those on the exam though. But I'll put them in there now just to remind you in case that happens. Okay, so common denominators, and then you can add or subtract. Number 20. It's just looking for the vertical asymptote. VA is what makes the bottom 0. So x plus 7 equals 0. Most of you can look at it and tell me the vertical asymptote. You didn't have to graph it or anything else. If it asks for the horizontal asymptote, okay, maybe it asks for that. That's that form. When it's in this form, that's the horizontal, -1. Okay. So I don't think I asked for it, but I might. So just to remind you in that form. So that was chapter 7 stuff. Number 20 and 17 or 16 are different forms of the same type of problem. Okay? This was just a regular fraction over here. We had this fraction. And then we had the plus or minus whatever goes out here. So if it's -1, the horizontal asymptote's -1. If that was +1, horizontal asymptote would be positive 1. So whatever that is. Oops, I don't need that page. I need to go to another slide. There we go. Is that the right problem? Same one that you had? Okay, I might have switched something up, but I don't know if I did or not. We just got rid of a couple, I think, is what we did. All right, so the special right triangles. We'll go through those real quick. Oops, I won't do that. I made the short leg x, hypotenuse is twice as long, and the long leg is always the short leg times the square root of 3. If it's a 45, 45 instead. The two legs are equal, and the hypotenuse was whatever the leg was times the square root of 2. All right, so we have to find the value of x and y. So since I gave you the hypotenuse, the short leg's half of that, so this equals 16 divided by 2, 8. And then the long leg, the y, equals the short leg, 8 times the square root of 3. So you should be able to do it in like, 2 seconds, right? 1 second for x, 1 second for y. And this is what we just got done doing, right? So this should still be familiar to your memory. The telephone pole casts a 24-foot shadow on the ground while the sun is shining. So you got the sun up here, right? You got a telephone pole. Here's the ground. Telephone poles usually make right angles, so we'll say that. It should go a little bit. But the sun shines on it, it casts a shadow, right? The shadow's on the ground. So there's the 24 feet. Okay? Tip of the shadow to the top of the telephone pole. So the shadow, the tip of it's down here on the ground to the top of the telephone pole. That means this is the 51-degree angle. Here's our telephone pole. X would be how tall it is. So there's our picture. Any questions with that picture? All right. So we had SOHCAHTOA we talked about in this chapter. If I know that this angle is 51, which side is x? Opposite, adjacent, or hypotenuse? Opposite. What's the 24? Adjacent or hypotenuse? Adjacent. So if I got opposite and adjacent, I'm using tangent, right? TOA. So I'm going to write my equation. Tangent of 51 equals opposite x over adjacent 24. There's my equation to solve it. Okay. What I told you guys to do is put it over 1, this side on the left, so you have a proportion, and this cross multiply. X times 1 is x. Tangent of 51 times 24. And that'll give you your answer. Make sure you're in degree mode. So I always hit my mode button, make sure it is in degree mode. So I'm going to put tan 51, close it up, and then 24. And it's 29.6 feet. Question. A was 3. B is 4, even though it looks like B should be 3 and A should be 4, right? That's okay. The picture doesn't have to match what you're told. All right. And you had to give me sine, cosine, and tangent. SOHCAHTOA, right? Theta is here. So sine of theta is opposite 4 over hypotenuse 5. Cosine of theta, adjacent 3 over hypotenuse 5. And then tangent of theta, TOA, here's theta opposite 4 over adjacent 3. So those types of problems should be pretty easy for it because that's the last things we did. It should, your memory should be okay with that. Any questions? Okay, remember, the exam has 9 free response and 20 multiple choice. So it's got 29 total, not just 23, but they're all those types of problems we've done. You can use both sides of that note card I gave you. Make sure you turn your book in, all right, by tomorrow. That way everything's done there. Addie, what's your question?
Do you want the answer to that?
No. Why are you always doing that to me?
Okay,